All right, so we are continuing our factoring trinomials. So we started off when a was 1, and this is what we were just talking about. So we have ax squared plus bx plus c. And I talked about this being easier factoring when a is 1. When the value of a in front of x squared is 1, the values of c will add up to b. And we do this idea of reverse FOIL. Okay, so I just wanted to go over an idea with you. So I'm going to use an old example, and I'm going to start with, I have an a squared minus 11a plus 18. Okay, so when I look at this, I see that the a value is 1. And so I want to compare this to what we're doing today. I would jump in and go into reverse FOIL because there is no GCF. If there's a GCF, I'm going to take that out first. Then my next step would be, here's my first, my outer, inner, and my last. That was our focus with reverse FOIL. So the first term is simply a times a. I don't have to think about anything else because 1 times 1 is 1. My last term has several factors like 6 and 3, 9 and 2, 1 and 18. So to get the right combination, when a is 1, I just have to pick the factors that add up to 11. Now, since this is a positive 18, I need two of the same signs. And since I want it to add up to negative 11, you see I got the right number, wrong sign. That's going to be a really important rule. If it's the wrong number, you're going to flip numbers. If it's the right number, wrong sign, you're going to flip signs. So I'm going to put in here a negative 9 and a negative 2. So why does this work out so easily compared to what we're doing today? When my factors of 18 add up to negative 11, that is because when I do the outside, that's what I'm looking for, the outer and the inner, I'm taking 1 times negative 2. That stays as a negative 2a. I am taking negative 9 times 1, which stays as a negative 9a. So these negative 2 and negative 9, those numbers stay and they add up to my middle term. Now, if I give you something different, let me give you something like a 3x plus 2 times just x minus, we'll say plus 4. This is already factored, but let's FOIL it. The first gives me 3x squared. The outside gives me a positive 12x. The inside gives me 2x. And the last multiplies to positive 8. So when I add these together, I have 3x squared plus 14x plus 8. So here's what I want you to see. This is my first term, and this is my last term, outer and inner, same idea. But my first term is no longer 1. When I look at this, are there any factors of 8 that add up to 14? 2 and 4, 8 and 1. Nothing's going to work. And the reason it's not going to work is when I took the 2 times x, yeah, I got 2x. But this 4 got changed because I multiplied it by that number out front, 3. So having a number out front changes this product when I multiply the outside or the inside. So now it's not so easy. Now, when I go to factor something like this, 3x squared plus 14x plus 8, I now have to consider what numbers multiply to get 3 and what numbers multiply to get 8. I'm still breaking it down. I'm still looking for the GCF, which there wasn't one, and then I'm going to make this 3x and 1x. Now, those are my only options, so I don't have to stress. It'd be different if it was a bigger number. But with the 4 and 2, 8 and 1, I don't know what combination to do, and this is where we get into trial and error, and I definitely want a pencil for this lesson. So if you bear with this, and let's say I put them in the order, I have it as a 4 and 2, a positive 4, a positive 2. Guys, the first works. I got it. The last is 8. I got it. But how do I know that I have the right outside and inside? It's literally called trial and error because I try to set a numbers. Is it the right combo? Well, when I multiply this, I get 6x. And when I multiply the inside, I get 4x. But you see that that adds up to 10x. I got the wrong middle number, right? So the idea is if it's the wrong number, I'm going to flip the numbers. So when I multiplied, I took 3 times 2. If I flip the 4 and the 2, I now have 3 times 4, which is 12x, and I have 2 times x, which is 2x. And that gives me the right combination. 12x and 2x is my 14x. If I would have tried 8 and 1, it would not have worked. I would have flipped it, it would not work. So that's literally, you say, these are the numbers that could work, and you try the different combinations. That's what trial and error is. So I'm hoping with this example, you see why I was saying this is easier. It's easier factoring because I can just look at these and I'll pick the right set because they add up. Because when I multiply the outside and inside, I'm multiplying by 1. That's the identity, multiplicative identity. But when I go to do here, that's changing the factor. So I actually don't know what combination is going to work until I try it. Sometimes I get it on the first try, sometimes I get it on the last try. So it can be a bit tedious. Okay, so jump to your example 7 with me. All right, find example 7. It should be right there after this set of notes. All right, so we're jumping in, and I need you to always look for, I'm going to remind you, GCF, because if I can take something out, it's going to make it a little bit less trial and error. I'm going to have smaller numbers to work with. All right, I'm going to dig in here, and I'm definitely going to use a pencil and an eraser. So first thing is there is no GCF. I do have a trinomial in standard form. So A is 3, and that's what's going to make this harder. B is 11, and C is 10. So this is still my first, outer, inner, and last. Now, there's lots of ways to do this factoring. We're starting with trial and error. You'll see some people make boxes to sort of show the multiplication table in the box. You'll see sometimes like the X where they put the number to multiply, which would actually be not 10, and add up. So that's not really going to work. Your factor's a 10. I know there's factors of 10 that add up to 11, right? 10 and 1, but that 3 is going to change everything. So what are your options for 3? 3 and 1. What are your options for 10? 2 and 5, 1 and 10. Do I need any negative signs here? I need the same signs, plus, plus, or minus, minus, and I want them to add up to positive. Okay, so I'm going to jump into my reverse FOIL, and I'm looking at this and thinking, 3x times 1x, or x times 3x, it doesn't matter the order, but that's my first set. Now, it's totally up to you what you try first. I have written 2 and 5, so I'm going to try a positive 2 and a positive 5. Basically, what I need you to understand is that we set our first and we set our last. This is me saying, okay, these are my only options, so I'm not stressed about first. I can check that off my list. But my answers could have a 2 and 5, 5 and 2, 1 and 10, 10 and 1. I have to decide. So I'm looking for the right combination for this outer and inner. I need the right combination for the OI. So you need to get in the habit of checking. When I multiply the outside, I get 15x. And when I multiply the inside, I get 2x, which adds up to 17. I didn't want 17. I wanted what? 11. Every set of factors needs tried twice, because when I had the 5 here, it multiplied by 3. So now let's give this a turn. So if I have the wrong number, I flip my numbers or switch my numbers. So you always need to try it twice. Now take 3x times 2, there's 6x, and 5 times x, there's 5x. So this 3 is changing everything. There is my correct middle number. So I don't have to try the 1 and 10. I've got it. It was a 5 and a 2 going in. So that is my final factored answer. Maybe I need to write that a little neater. So it's 3x plus 5 times x plus 2. That is my final factored answer, just to make sure we see that. All right, so look at B. There's a lot more going on because my numbers are a little bigger. I still have my first, outer, inner, and last, but yeah, my first could be a 5 and 3 or 15 and 1. So I do want to consider all possibilities. I hope to not have to go through it all, but write everything down. All right, my options for 8. I need a positive 8 that adds up to positive. So 4 and 2, 8 and 1. So again, you want to show all your options. All right, I'm going to jump in. I'm leaving myself some room for some chicken scratch. I would have a 5y and a 3y. That's what I chose to do first, okay? Now, the next that I'm picking, I'm going to go ahead and pick 8 and 1 because I want to show you. Normally, I just go in order. So a positive 8 and a positive 1. I'm going to put those in there. When I go to check, your first is good. We know it's 15y squared. Your last, 8 times 1, is 8. The question is, did you get that right combination for the middle? So check your outside, that's 5y. Check your inside, that's 24y. Okay, that's not the right number, agreed? So what you would do is you would flip these numbers, and I can tell you it's not going to work because look, now I have 40y and 3y. So I'm going to throw out the 8 and 1, and I'm going to start again with 4 and 2. Might need a better eraser. So start again with 4 and 2. Now, scratch paper is great, but if you're going to turn in your work and all you have are perfect answers, I'm going to say, where's your work? Make sure you have your scratch paper with you and numbered, or make sure you do some work off to the side. I'm going to put in my 4 and my 2. Okay. Oh, I think nope, I have it. Look, 5y times 2 is 10y, and 4 times 3y is 12y. There's my 22. Now, if that didn't work, I would have flipped the 4 and 2 and tried again. And here's the downfall. If that didn't work, I would have had to restart and try everything with 15 and 1. So do you see that I'm trying the different combinations? All right, so my final answer, 5y plus 4, 3y plus 2. Now, the order does not matter, but the 5y has to be paired with 4, and the 3y has to be paired with 2. Okay, now, what's different here, these are all a does not equal 1. What's different here is now I have a negative sign. So that's going to throw a little bit more into the mix. But if you remember my rule, I kept saying, if you have the right number but the wrong sign, flip your sign. So signs are an easy fix. All right, so let's start. No GCF. Remember your first, outer, inner, and your last. What are my factors of 6? 2 times 3, 6 and 1. What are my factors of negative 4? Well, I could have a negative 2 and a positive 2, or a negative 1 and a positive 4. Now, we could also flip this. I don't normally write all the negative signs because I'm going to show you it's a pretty easy fix. All right, now here's my other decision. I typically start with the split, the 2 and 3. I mean, it could be 6 and 1. I normally start with 2 and 3. So I'm going to start with a 2z, and I put a line through my z's, and a 3z. Now, the other thing I do, anytime I have a number that's a perfect square, something times itself, I pick that first because I don't have to think about, if these are both 2's, I don't have to switch them. Now, I can tell you this is not the right factoring, and how can I tell you that? You can cut down your trial and error. You know how there was no GCF at the beginning? No GCF at the beginning at all? Well, then these 2's can't have something in common, can they? Do you remember at the other problems, if you had a GCF at the end, that means you missed something at the beginning? If there was no GCF, I can already throw this out. I don't have to try the 2 with the 2. But let's just show it. That would be 4z, and that would be a negative 6z. And that does not give me negative 5. But I would not even waste my time trying this. Now, if I switch signs, if you remember talking about signs, if I switch the signs, I just want to show you that now I have a negative 4 and a positive 6. So I would either get a positive 2z or a negative 2z. So if I get the wrong number, I just switch numbers because the signs are an easy fix. So let's throw that out. I'm going to throw out the 2's, and I'm going to try my 1 and my 4. So let me tell you this. Again, if you catch this, this is going to help you. I would never put the 4 here. I can tell you right now it's not going to work because there shouldn't be a common factor if there was no GCF. So 2 and 4, it's not a good combination. You're just wasting your time, but it still will show you it won't work. That's a negative 2z, and that's a positive 12z. So that's not what I wanted, but again, I didn't even have to try that. So let's try. So basically, this is the only thing I would have had to try. The 1 and the 4. Now, I know my signs are different. We'll fix that if we need to. I honestly didn't have to try the 2's because I shouldn't pair any common factors with this 2. Okay, so we have 2z times negative 4 is negative 8z, and 1 times 3z is positive 3z, and I do get my negative 5. So I'm done. If I would have gotten positive 5, flip the sign. So wrong number, flip the numbers, wrong sign, flip the signs. If none of this worked, I would have gone back and tried again. So my final answer here is 2z plus 1 and 3z minus 4. Now, you don't have to rewrite your final answer as long as I can see it. This is just a check. I'll always have a kid who does this, and then they refoil the whole thing and circle that. That's just my check. And I didn't show the whole refoil. I was just showing the outer and the inner. I know that the first is 6z squared. Outer, inner here, and I know the last is negative 4. But you do want to double check yourself. Okay. Unfortunately, we have even more numbers to deal with because 15 could be 5 and 3 or 1 and 15. And negative 12 could be a negative 3 and a 4, a negative 2 and a 6, or a negative 1 and 12. Now, I could also list all the opposites, right? 3 negative 4, 2 negative 6, 1 negative 12. I don't take the time to do that because I don't want to call it an easy fix, but again, wrong number, switch the numbers. Wrong sign, switch the signs. It's a quick fix for signs. All right, so what do you guys want to try? Should we try the 5 and the 3? 5z, 3z. Well, that's what I'm going to try. All right, and then I think I'm just going to go in order, guys. It's literally called trial and error because I'm going to try something. If it's wrong, that's an error, and I'm going to try something again. So what do you want me to try first? Do you want me to go in order?
Yeah.
Okay, here's what I won't waste my time with. See how there's a 3 here? I would never put the 3 here, the 6 here, or the 12 here. They should have no common factor. So I just cut my trials down in half by looking and saying, hey, I don't want any common factors. There was no GCF at the beginning, so there should be no GCF. So I don't have to try the 3, 6, or 12 over here. I just have to put in the 3 and the 4. Now, if I have this, the first is 15z squared. The last is negative 12. If it helps you to write that out, go ahead and do it. My focus is the outside and inside to make sure I got that right combination. The outside is positive 20z, and the inside is negative 9z. I got 11. What did I want? So I got the right number, just the wrong sign. So what do I do? Flip your signs. So wrong number, flip numbers, wrong sign, flip signs. So now look, I get a negative 20, I get a positive 9, there's my negative 11 that I wanted. All right, so I'm just going to rewrite my final answer. 5z plus 3 and 3z minus 4. So that was pretty nice. If that didn't work, we would have tried negative 2 and 6, but again, I would have put the 6 over here. We would have tried negative 1 and 12, I would have put the 12 over here. If none of that worked, I'd go back to 1 and 15. All right, so we are moving on, and you can see that my title here has that we have trinomials with 2 variables. Okay, so we've already done some with this. We're still working on the idea of trial and error, but there's another variable in play, so don't let that throw you off. When I go to do this, I'm looking for a GCF, and they don't have one. So I'm looking to see, can I take a variable out? And I can't. When I go to split this up, I'm going to have a 4 and a 4, 8 and 2, or 16 and 1. I think it's really important to list all possibilities in case you have to go back. 25, 5 and 5, or 1 and 25. Now, here's the deal. I have a positive 25, so I either need positives or I need 2 negatives. And the only way to get a negative number is if these are negatives. So I'm going to have the 2 negatives to multiply to positive, and eventually they will add up to negative 40. Now remember, that front number is changing things. When I go to do my problem, I'm going to help myself. I know that I'm going to need something with a y. So my final answer, and I have it right here. Well, I don't want to show it to you. My final answer will have something times something will give me the y squared. So I'm going to put that in there. Now, whenever I have duplicates from perfect squares, I'm going to try that first. So I'm going to put in the 4x with the 4x. This is, I mean, honestly, it's sheer laziness on my part. Guys, if this is the same number, do I have to flip anything? No, because the outside is going to multiply by 4 and the inside is going to multiply by 4. So anytime I have double digits, I normally put those in so it's a one and done trial. I don't have to flip numbers. And I'm honestly going to use my -5 with my -5. Okay, so first, 4x times 4x, 16x squared. Got it. Last, -5y times -5y, positive 25y squared. What I'm really digging in to look for is, did I get the right combination? Well, the outside is a -20 with an xy, right? 4x, -5y, I got my xy. The inside is also -20 with a yx or xy. And multiplication, the order doesn't matter. This adds up to my -40xy. So I got on the first try. If that didn't work, I would have jumped to trying the 1 and 25, and then I would have come back to the drawing board and tried again with 8 and 2, 16 and 1. So we could have been here trying this problem a lot. Now, we haven't done this yet, but we will. Do you see this is something times itself? So in this case, your final answer is 4x minus 5y quantity squared. This is called a perfect square, which is actually easier to factor, and we'll talk about recognizing those, but I want to throw that out there now. Okay, now, next one. We have two variables. We definitely have a negative sign here, so we have to consider that. So the downfall of 18 is it could be 6 and 3 or 9 and 2 or 1 and 18. Don't discount that. Sometimes we use this. The good news about -2 is it's prime. So I only have one set of factors, and again, I can switch the negative sign very easily. So the 18 is what's going to take some effort. So here's what I'm looking at. I'm going to put in my 6x and 3x because that's my first set. So I'm going to try that. And when I go to pair this, don't waste your time. There's no reason to put the -2 in here. Because do you see that 6 and 2 have a common factor of 2? Did you have any common factors in the original? So if I put this in, it's guaranteed not to work. So that's going to save me some time. But let me just prove it to you. This would be 6x, and this would be -6x, which adds up to 0. And I wanted it to add up to 5xy. Oh, I lost my y's. Did you guys get your y's? So that should have been xy, xy. Okay, so that didn't work. Honestly, I wouldn't have wasted my time. Because I knew that I shouldn't pair the 2 with a common factor of 2. All right, so I'm going to make this a 1 and a 2. The outside is positive 12xy, and the inside is -3xy. And that adds up to 9. If you switch the signs, that just makes it a -9. So switching signs doesn't help. I'm going to throw out the 6 and 3, and I'm going to move on to the next set. Okay, so let me restart this. I know it's a little bit of a mess. All right, hopefully you can do better at erasing than me. So I'm restarting. I got a little mess here. I'm going to put in this as a 9x and this as a 2x. Now, when I go to do this, I have a 2 and a 1. I'll never put the 2 in here because see how it already has a 2. So I'm automatically putting the 2 here, and I'm automatically putting the 1 here. Now, the signs really don't matter to me. I'll fix those later. I just used the sign that I had here. Okay, so 9x times -1 is -9xy, and then 2y times 2x is positive 4xy. Okay, that gives me a -5xy. What did I want? I wanted a positive, right? So wrong sign. Just switch your signs. So now I have a positive 9 and I have a -4. There's my positive 5. All right, so that is my final answer. And we had this discussion. The order, if I have it as 9x minus 2y and you have the other one first, the order does not matter as long as you have them paired. The 9x has to go with the -2y. The 2x has to go with the positive 1y. All right, so we have two more problems to try. Pause this video and give them a try. I want you to see how you would lay them out. All right, one of the things that you should notice is even though there's not a GCF, there's definitely a negative number out front. We always want the ax squared to be positive. That's going to help cut down on thinking. Having a negative out front makes all the signs weird. So you would have to consider the signs, and it's much easier to work with. So even though there's no other GCF, I'm going to take out a negative 1. That leaves me a positive 2x squared, a positive 9x, and a positive 10. So whenever you divide out that negative, all the signs change. That negative 1 has to come along for the ride, though. Don't lose it, okay? Now, what are my options? 2 and 1. My options are 5 and 2, 1 and 10. And by taking out that negative, I'm not worried about the signs on the front. I always leave the signs on the last term. And since this is a positive 10 and they're going to have to add up to positive, I know they're both going to be pluses. So that's good. What numbers should I not put in here? Well, if I use 5 and 2, I'd put 5 in here. I wouldn't put 2. If I use 1 and 10, I'd put 10 in here. Or I would not put 10 in here. So that's going to cut down on my trial and error. And I think I've got it on my first try. The outside is 4x and the inside is 5x. So there's my 9x that I needed. So I've got it. Now, you can have a negative 1 or just a negative sign. You would have 2x plus 5, and you'd have x plus 2. Again, the order does not matter, but it does matter that they're paired properly. If you had not taken the negative sign out, you might have it as a negative 2x and a negative 5, and then this would be the same. So one set of signs would be the opposite, and I think it's much easier. Now, look at the last one we're doing. Not only do you have a negative sign, but once you take that negative sign out, do you see it's easier factoring? Like this is actually a really good one. So take out that negative 1. You don't want to deal with it no matter what, even though this is the easier one. We don't want to deal with that negative sign. Everything else changes. And the reason I'm saying it's easier is because A is 1. And when A equals 1, factors of C add to B. I don't have to do trial and error. All the other ones, I had to do trial and error. So my options, I really don't need to do this in pencil. I think I can get it. X times X, I don't have to think about that. My only options are 5 and 1, and they do add up to 6. So a positive 5 and a positive 1. Now just double check yourself, and this is the big difference, and I'm hoping it comes full circle. Why don't the 5 and 1 multiply but add to 6? Because when I multiply the outside, it's 1 times 1, there's 1x, and it's 5 times 1, there's 5x. So by having an a value of 1, it doesn't change the factors when I do the outside and inside. So my final answer would look like a negative, and then x plus 5, x plus 1. If you would not take out that negative in the beginning, it is much harder to factor, and you have to think more. Okay. So while I have this on, I just want to jump and do one more, and this is off of a worksheet. So I was looking at this first one, and I was looking thinking, oh, those numbers are really big. So 96 has lots of factors. So my goal is to not have more factors than I need. So I know that these are all even, so I can definitely take out a 2. Can I take something higher than a 2 out? Well, if I'm not sure, I could try. I could use my calculator. If I take a 2 out, I'm left with 7b squared minus, I think it's 62b plus 48. Anyone want to verify that for me? Is that true? 124 divided by 2. If my numbers are wrong, then it's not going to factor, and I'm going to be spinning my wheels. Okay. Now that I have that, I did take out the GCF because 7 doesn't have anything in common. That's really helpful. So here's my 2. I'm going to break it down. My only options are now just 7 and 1. So I don't have to stress about that, but I do have a lot of options for 48. And that would be 4 and 12, 2 and 24, 3 and 16, 1 and 48. I don't know if I'm missing anything else. So that's what I'm going to try. 6 times 8. So I would probably start with the 4 and 12. And I can see that my number is going to be too big because that's already going to be 70 and then another 14. That's going to be too big. So then I would try to flip it. And some people just type it in their calculator. So I'd have 28 and 12. That's not big enough, so I'm going to throw that out. 2 and 24. 24, I want you to think about that. 7 times 24 would be way too big. So I would put the 24 here and the 2 here. And that's 14 and 24. That's not right. Oh, did anyone want to remind me? I should have what? 2 negatives. Okay, so that's not going to work. I would try 3 and 16. Well, 7 times 16 is too big. So I would try it this way. And that's 21. That's not going to work. I'm going to jump down to 6 and 8. And again, some people will literally just type it in their calculator. So I'm going to put the 6 here and 8 here. And that gives me negative 56. I think I got it. So what am I talking about? If you're not wanting to do this all in your head, I'll have a lot of people who will just take, okay, 7 times negative 8 plus negative 6 times 1. And they'll just type it in the calculator. And that's how they do their trial and error. So it's going to take some effort. And always, always take out your GCF.